So, dear ladies and gentlemen, the future of AI agent. Professor Pascale Fung is the Senior Director of AI Research at MetaFair, an expert in the World Economic Forum, Future Council, member expert of UN advisory boards on AI, and was invited by governments and in Europe, but also in Saudi Arabia, Japan, Singapore. And really important, she met with the late Pope Francis in 2023 to discuss AI ethics. So, children of God, please, with a warm welcome, please, Professor Pascale Fung.
Thank you, Daniela. Thank you, ladies and gentlemen. I'm very happy to be here. I did all my studies in the US and spent 20 years as a professor in Asia. Last year, I moved to France, Paris, Fair in France. And I strongly agree with Peter and Jonas' earlier narrative on we need European valued centered, human value centered AI development and research. I also strongly agree that here we have opportunity to provide the next frontier of AI research. So FAIR is the research arm of Meta, and I'm here to tell you the good news from FAIR in Meta. Yes, so we all agree, and the previous panelists have talked about the need for AI, economic development, the future of precision medicine to make us healthier and to educate our next generation better, and to use AI for economic development. That's not the only thing. I believe AI is enabling us to have another time in history, another renaissance in humanities, in the arts, and in science. AI will be used, it's already being used by artists to create new forms of art, by writers and creatives to create new forms of humanistic studies. And there are people working on ethics of AI, and when we talk about ethics of AI, we're actually debating the ethics of different cultures, human societies. And AI, of course, is being used, starting to be used in discovering new scientific theories. And so I believe AI will bring about another renaissance in the history of humanity. And of course, Europe was the bed of renaissance the last time around. And I think we can be, again, a very important, critical part of this, the second renaissance enabled by AI. So Meta has long been an industrial leader. It used to be called Facebook. And we started doing AI back in the 2000s already, using AI to enable recommendation engines and ads and so on. And then FAIR was created about 10 years ago by a European, French-American researcher named Yann LeCun. Actually, last time I came here on this stage was with him at another event in 2017. So in FAIR and in Meta, we believe in open science and open research. Why do we believe in that? Because unlike many other technological innovations in our human history, AI really is a full stack, it's a multi-stakeholder co-development technology. It came out of the fruit of scientists in different disciplines. My first published paper was here in Europe in the 90s. So AI came from the field of signal processing, machine learning, mathematics, statistics, pattern recognition, but also cognitive science, also computational linguistics, also from philosophers. So AI has always been a multi-stakeholder development. So we need to have an open science approach, to continue to have this open science approach, so that we can co-develop AI with the entire society. Every one of you here has a role to play, and you are already playing significant roles in the development, in shaping the future development of AI. So to enable that, we need to open source what we do, our scientific models and so on. Another reason to enable for AI development is I can stand up here and tell you Llama is the best this, our other model is the best in that, but only through open source can you actually verify that claim. Only through open source can the scientific communities collectively benchmark what we do. All right? So people, back in 2023, people were saying, what can ChatGPT do and not do? And I actually decided to, with my research team, do a benchmarking paper that benchmark ChatGPT on 23 standard natural language processing, open source natural language processing tasks and benchmarks. So only through open source can we collectively verify the scientific claims that's made by various players. So that's the game of science, open source. Now, this is about I already talked about the history of AI a little bit. So we founded FAIR, Jan LeCun co-launched the FAIR Labs in 2013. FAIR stands for Fundamental AI Research. And the role of FAIR in Meta is we are the upstream innovation center. Right? You see the products in Meta. Today we have FAIR, and then back in 2016, PyTorch was created, and I think many of you are familiar with this. It's the open source platform for development and research of AI today. OpenAI uses it, Google uses it. So that's the downstream from our fundamental AI research. And 2022, around the time, we had our first Llama model. And did you know that the first Llama was developed in Paris by European researchers in FAIR? Right? So FAIR is an international research lab. Even Meta is an international innovation center because we have many researchers from all around the world. They can be sitting in Menlo Park or New York. A lot of us are in Paris, and some in other parts of Europe, in Switzerland, in UK. You can debate whether that's Europe. I think it's Europe. So Llama came out of Paris, FAIR Paris. And Llama then was spun off into an organization called Gen AI, which today is the Llama team. So they developed Llama. So what do we do in FAIR? We continue to do fundamental AI research. We look at the technology of tomorrow. We are already looking at beyond Llama, beyond Gen AI in the future. So there are researchers. I will go to the next slide. So we have different research teams in FAIR working on the building blocks of AGI, what we call AMI. The mission of FAIR is to build the what we call advanced machine intelligence. So it's AGI with a meta take. So different AMI capabilities, and you can see some of this here. And I want to mention something. I was very happy to hear the mention of low-resource language development, because I personally work on low-resource language development since the 1990s, first in speech, then in languages. We have 6,000 to 7,000 living languages in the world today. And the major language models indeed perform much better in the major languages, and not so well in the low-resource languages. So in FAIR, we, in a few previous years, have rolled out a product called NLB, No Language Left Behind, which worked on more than 300 languages in the world, and they were benchmarked on 300 languages in the world. They're open source. You can evaluate its capability. Right? Some of this is in Llama, some of it not yet. But we collaborate, for example, with UNESCO to open source this kind of language translation for more than 300 languages in the world. And I was very touched to hear at the Paris Action Summit, many developers from the global south in Africa, in South America, talking about how they use these tools to develop applications in their local language. And today in FAIR, the same group is working on towards 1,000 language, full machine translation for 1,000 languages in the world. So they are working on the next technology for low-resource language translation with very few samples. So today's generative models are not good at learning things from very few samples. But for low-resource language translation, it's a very good benchmark of the future architecture that we are developing, exploring in FAIR. For example, you must have heard about the world modeling and the JEPA models that Jan has been talking about. So we are exploring world modeling in FAIR collectively with different hypotheses, some pursuing the generative hypothesis, some the JEPA hypothesis, some pursuing the reinforcement learning hypothesis. We would like models to be able to understand the physical world around us and also the mental world of humans, of users. So this research is just the beginning. I'm very excited being in FAIR at the forefront of exploring this line of research. And another topic I'm going to talk about, I'm going to focus on embodiment. So that's one of the building blocks of AMI or AGI, which is embodied AI agents. And I'm going to talk to you about this. And we have a very big group effort on alignment. What is alignment? It's about responsible AI, how to align our AI models to human interests and human preferences and different cultural and philosophical contexts. So this is a rigorous line of research, right? We don't just look at regulations and guidelines. We must translate that into actual codes. How do we operationalize that into actual codes, into machine learning? So there are a group of people working on alignment. We also have people working on, I mentioned already, communication language. People, of course, working on reasoning and planning. The aforementioned world modeling, that's the focus of reasoning and planning. How can AI models reason and plan better? If you just use generative models today, they are optimized to predict the next word and the next pixel in an image. They're not optimized to actually reason and actually plan. So we are exploring the architecture that will allow us to create what we call objective-driven AI. All right? Generative AI is very powerful, and the fact that they are only trained to predict the next token, next pixel, and yet able to manifest all this kind of capabilities and task completion is a great discovery. FAIR actually worked on the predecessor of ChatGPT, such as we had this Blender bot, we had a system called Galactica. We were already doing collectively. I don't mean just FAIR, but also, of course, OpenAI at the time. Google was doing the same line of research. Transformer came out of Google, which was based on PyTorch, and OpenAI did a ChatGPT based on Transformer and FAIR. It's always been this collaborative work. So generative models has its great capabilities, but it has its limitations, right? Because they are not optimized for reasoning or for planning. So today, if you've been using this kind of Gen AI models, you must have the feeling that it doesn't always do what you want to do. Even when you say something and it says, yes, I will compress the data that, like you said, but it's saying yes, it's doing something else. Why? Because it's trying to optimize for multiple objectives. The objective of answering user requests, the objective of speaking fluently. That's what ChatGPT and all these Gen AI models love to do. They want to sound professional, they want to sound expert-like. And the objective of preventing harm, and the objective of doing many tasks at the same time. So Gen AI today, that's why you need fine-tuning for specific languages. You need fine-tuning for enterprise applications. So please do fine-tuning, because Llama is there, free for everybody to use as a foundational model and to fine-tune for all these different purposes, right? Now, but we are looking at different architecture that will be more efficient, that will be smaller, and that will be objective-driven. The next part of the talk, I'm going to focus on embodiment. You're probably familiar with all these AI assistants. I've been working on conversational AI since the 90s, right? At the beginning, we have AI assistants that handle call center requests on the telephone. You call and they say, AT&T, for example, at the time will have a service that's, how may I help you? And then some of you old enough, you remember those AI assistants in call centers. And then in the 2000s, we saw Siri and the other assistants come out on smartphones, and you talk to it, and it does different things. These assistants were kind of error-prone, but also it was very simple. It does one thing at a time. Very simple things, like find me a restaurant. give you a whole bunch of search, right? It was voice search. But today, we have evolved from AI assistants to agents. 2025, I actually call it the year zero of AI agents, right? Because these AI agents are kind of learning. So what's the difference between AI agents and AI assistants? AI agents are more autonomous than assistants. They can carry out tasks that are higher level, right? It can carry out tasks that will require more than 100 steps of humans to do, right? Search is just one step. Replace search by assistant. You just replace it by voice command. But if I want an AI agent to schedule my meeting, I just want to say, please schedule the next meeting between me and Mark Zuckerberg. I don't do that, but very often. But there are a lot of complexities. Imagine if Pascale wants to have a meeting with Mark Zuckerberg, there are a lot of complexities. It needs to look into what's the purpose, the means, the scheduling, and what is the good contacts, and so on, right? Agents should be able to do that. AI assistants cannot. So we're working towards this kind of agents. And today, the agents are, you see demos. And on the other hand, you can build your own AI agents. I always tell startups, you can build your own AI agents by fine-tuning, instruction tuning on llama models. That's the advantage of open source foundational models. You can take them and you build your own agents, purpose-built AI agents, right? Now, what I want to talk to you about is beyond that. Beyond what I call web agents or digital agents, llama agents, or what you see out of Claude agents, right? What they can do today is use tools on the internet to complete tasks for you. And we also have a benchmark for these agents called Gaia, by the way. And people can compare different web agents in terms of their capabilities and tool use. I also want to talk to you about embodied AI agents. They are embodied in avatars, 2D, 3D avatars. In Meta, we have other organizations, Reality Labs, developing these 2D, 3D avatars. So AI agents embody in them. AI agents embody in wearable devices. Why do I call them embody? They actually embody in the human user. Because on the AI agents on the wearable devices, they will see what I see, hear what I hear, right? So this is this is what embodied AI agents are coming in the future. And you might have seen the Meta device called Orion under development. So in a few years, you imagine that you won't be using your smartphone anymore. You will be wearing this holographic, this kind of wearables with holographic displays. You will see your computer, everything just like this. You can be sitting here pretending to listen to me and working on your computer with your, with your fingers like doing this, and nobody would know. You can also listen to me and check whether I'm saying something is true immediately in your devices, right? It's all holographic. Well, the idea is to break down the barrier, right, between human to human. Because the smartphone is, I see people in restaurants looking at their smartphones, right? You want people to actually connect with each other more with the added benefit of technology. So there will be in wearable glasses where you will get the information you need without putting a barrier between you and your interlocutor, your friend, your colleague, your client, your family. You'll be continually interacting with them and while being augmented by technology. Truly, technology augmenting human and not putting a barrier between us. And then we go to robotic agents. So today I'm very excited. Since I was 7, I wanted to build robots. I went into AI because I wanted to build robots, because robotic development was too slow. The mechanical part of robots development has been very slow. So I went into AI to build the brain for robots. But today we finally see the merge of the two fields, the merge of robotics with AI into something we call robotic AI agents, right? When robots are equipped with brain, of AI brain, they become much more intelligent. They can do all the things that I imagined that we wanted to do when I was 7 in the science fictions, right? So what are the capability we built? So wearable and virtual agents, what do these agents need, the capabilities they need? Number one, physical world modeling. When they are in They are agents with my egocentric point of view. They need to know what I see, what I'm experiencing. The laws of physics, generative AI cannot do that today, very badly. They need to know the laws of physics, what's happening around you, what is about to happen. If you cook, if you put something too hot, you might burn yourself. It needs to know that. At the same time as you're doing this kind of human actions in the physical world, it needs to know the human mental world. My daughter asked me, I want to have a wearable agent who is my math tutor. It just looks at me when I'm doing my math homework, but it does not tell me the next step solution. It knows what I know and try to hint as a good math tutor should do. Today we don't have that. We have generative models trying to solve math problems, but not tutoring. So coaching tutoring requires these agents to understand the physical world and the human mental world. Going into robotics, even more so, they need to understand the physical world, right? The laws of physics. They need to control the actions of robots. Today, one of the biggest problems in generative models, which I've been working on many years, is hallucinations. All right? Hallucination is AI giving you untruthful answers. Okay, if it's a text answer, you don't like the answer, you go for search, maybe you can solve the problem. Imagine a robot hallucinating, flailing its arm around your kitchen. You don't want that, right? You don't want the wearable agent tell you to jump when you shouldn't jump, right? So you don't want that. So hallucination, we cannot have models hallucinating. That's another reason we work on architecture such as JEPA, because we want architecture that's fundamentally objective-driven, fundamentally built to have guardrails, and not as like a filter at the end. Generative models cannot do that. So in robotic agents, we want to build, we are actually coming out already publishing some first results on robotic agents, robotic action planning using JEPA. You can Google the paper, it's all open source, open science. You can verify that. You can take that home and try it yourself and build your robotic agent based on that, right? And don't forget, of course, there are a lot of ethical issues about agents and embodied AI agents. Agents are more autonomous than LLMs. Embodied agents are autonomous AI agents in the physical world. So the implications and the danger, so the risk can be detrimental, more detrimental than if it's just a web output, right? So we have a large team of researchers, myself included. We're working on models that are fundamentally taking AI safety into account, right? I don't want to give up Gen AI, generative models. I use generative models and improve them, and then use them as building blocks towards objective and safe AI. So that is one part or important part of all AI research today. And with that kind of research, we can ensure that embodied AI agents will unlock human potential. Imagine the applications we can have with this kind of agents. Nobody's touching it. Nobody's even talking about it, except me and some of us. This is my first public talk on this topic. Before, I've only talked internally, right, since a year ago. And now we have some initial results. And I'm very excited to see, because as a scientist, I want to have wearable agents that can tell me how to set up my experiments, right? Chemists who can have wearable agents that tell them precisely what portion of chemistry solutions to use, and so on. So imagine the human potential that can be unlocked by this kind of AI, future AI models. And imagine the renaissance we can have that will elevate humanity. Technology is not there to prevent humanity from progressing. Technology is here to enable us to progress further, not just technologically, not just economically, but also humanistically, right? Elevate our thinking, elevate our civilization, and so on. Now, to end this talk, I have 2 minutes, perfect. I'm gonna show you a video illustration of what I see as family of embodied AI agents working together. So I'm from France, so I'm using a very bourgeois example of a dinner party, which I love to have in my house When I moved to Paris, I picked an apartment where I can have a huge space for dinner parties. And so for dinner party, how do I plan a dinner party? Before I plan it, imagine this is the future, not today, right? Next year maybe. 2 years later, I have my Orion glasses and I have my web agents. I say, okay, I want to have a theme for my dinner party. Okay, what's this theme? Okay, and I start to interact with the online agent and say, okay, what could be the invitation list? What kind of people I should get together at this dinner? Some philosophers, some engineers, and some writers, and maybe some filmmakers, which I happen to know in Paris. And let's have this theme, and suggest some menu. Right, what are these menu suggestions? Okay, thank you. I take this menu and I go grocery shopping. I love to go in grocery shopping in Paris because I love touching the produce. So
can you help me figure out what to make for dinner tonight?
Can you mute
Hopefully something where I can use some of these fresh veggies and stuff for my basket.
Store, I look at different produce, and I have my Meta glass Orion telling me, here, these are the produce you need for your menu, for your dinner menu. But then I'm like, these radishes are not so good looking. I want to change the menu. Okay, it will change for me. I say, okay, you can replace this by this, while staying in the theme of my dinner party. So I go shopping and I get all this, and I have them delivered through e-service, maybe Amazon delivery, maybe others, and to my home. And I go home, I prepare, and I start cooking. And I will be cooking with my I will be cooking wearing my Orion glasses, and I already have the menu. And I'm actually a pretty good cook. I'm not like zero, I start cooking, but then it will tell me, oh, but this is a new dish I want to try. Instead of, now when I do that, I look at the menu, I do it, I'm not so sure, right? So the glasses, the agents will follow me, it knows the plan, and as it watches me cook, it will hint to me when necessary only. If not, it doesn't say anything. What's the next step, right? No, back. I cannot go back. Anyway, so it will hint, and I might, suddenly I put things in the oven and I have a phone call. So I went to get a phone call, talking to my friends, telling them how to get to my home. And then the glasses will say, hey, don't forget, it's 5 minutes, you need to turn off the oven, right? So this is how wearable agent helps me. Then my guests come for dinner. My dream is to have my robot, Spot, serve drinks to my friends when they arrive. Go to the kitchen, prepare the drinks, and serve them, so I can just talk to my friends instead of going between the kitchen to my friends. And then my friends are all sitting in my dining room, and they say, Pascale, come join us. I said, no, I've got to make drinks. I got to cook, right? I want a robot to help me doing that. That's the whole idea of embodied AI agents. They need to take away the chores, physical chores and mental chores that we don't want to do, to allow us to spend more time with our friends and families. So, okay, then we have our dinner. You know what I do not like to do in the dinner party is after the dinner party, when I say goodbye to my friends, cleaning up. All right? I want a robotic agent to clean up. Today, I have a robot vacuum cleaner that vacuums the whole floor. Great. But who's cleaning the table? Who's bringing the dishes to the dishwasher? Right? Who is putting the things from the dishwasher back to the racks and so on? I want the robot that would do all that. And that's what FAIR robotic team is focusing on, domestic robots. So I want cleaning robots, I want ironing robots, right? And cooking assistant, or sous chef, let's call it. So this is the vision, the future vision of a family of AI agents working together to improve my life and your life. And there will be many other beneficial applications come out of this, and we're working towards AMI in FAIR, in FAIR Meta. Thank you very much.
Thank you so much, Pascale. Thank you. Before you leave, just one question. When do you expect you have your next dinner party with your robotic dog?
Robotic dog, it's maybe 2-3 years.
Okay.
Or 5.
Yeah, okay.
Depending what the dog can do.
You're all invited, by the way, because no clinic is necessary then. And
we can have the party here.
Yeah, perhaps that will be an idea. And if I may ask, could you tell us perhaps just in a few words your meeting with the late Pope Francis? Was it an interesting experience? Was it more a ceremony or?
It was actually, he gave a very important speech about the benefit of how can we make technology to benefit humankind, in particular in healthcare and medical care. In particular, he talked about this. You can look it on the internet. His speech contains the line that for medical research, for AI, precision medicine research, we will be selfish if we do not want to share our data and yet want to benefit from the treatment of the latest technology. Meaning that I don't want to share my patient data, but I want to use that technology to treat my illness, the technology that has been trained on other people's data. So he said that would be very selfish. That's what he said.
Okay.
And we talked about the various aspects of beneficial AI and how we can enable, use AI to enable a healthier and more prosperous humanity in the future.
Ladies and gentlemen, Pascale Fung.
Thank you.
Thank you.
Thank you.
Thank you.